Chapter 4.5, Numerical Integration, the Trapezoid Rule. Day 3, Numerically. Right, last 2 days we looked at Trapezoid Rule. Day 1, we did analytically with the equation. Day 2, we did it graphically. Today we're going to look at it numerically, meaning in tables, using tables. It's not going to change. We're going to still use the same equation. The only difference will be if sometimes we don't have this common base. In which case, if we don't have the common base, we're going to have to do each trapezoid individually. All right, our first example, we're going to have that common base. Right? Estimate the area underneath or bounded by a stream in 2 straight roads. Very similar to a problem we did yesterday, except yesterday we had the graph. Today we got the numbers. Estimate the area basically underneath y from 0 to 500 with respect to x. All right, so let's use these trapezoids. We see we got 1 trapezoid there, 2, 3, 4, 5. We're going to use 5 trapezoids. So this will be 500 minus 0 over 2 times 5, which is 10, times this first height will get used once. These heights all here will get used twice, so we'll do 2 times 125 plus 2 times 120 plus 2 times 112 plus 2 times 90. And then this one, because it's only used once, 90. So that's the estimate of that area between the road and the stream as we calculate it. All right, we'll do 50 times 125 plus 250 plus 240 plus 224, 180, and 90. There we got 55,450 square feet, or no, square meters. Right? That's the trapezoid from a table. It's not any different, just the numbers are calculated for you. All right, here's another example. Estimate the area underneath f of x from 0 to 7. This time, you'll notice our trapezoid heights are inconsistent. No big deal. Right? No big deal. We just don't throw them all together like this. We do them separately. Oops. Put that back. We do them separately. So we got 3 trapezoids. The first trapezoid, the height from 0 to 1 is 1. And then we add our bases. 2 plus 3.5, 5.5. The second trapezoid, the base from 3 to 1 is 2. Add the heights, 7.5. And the last trapezoid from 7 to 3 is 4. Add the heights. Right? Instead of doing them all at once, we do them separately and work that out. Right? So this estimate is 0.5 times 5.5 plus 7.5, because a half cancels, and 2 times 7 is 14. 24.25. Right? Let's go one more. Suppose that a device is placed in a race car that measures the instantaneous velocity at 2-second intervals. The data is shown below. Use the trapezoid rule to estimate the total distance traveled by the car between 0 and 14 seconds. All right? So this race car supposedly goes from 0 to 66 in 6 seconds. Must not win a lot of races. All right. First off, miles per hour and time in seconds, we need to convert. All right? So we need to multiply, we got miles per hour. We need to multiply to get rid of miles, multiply to get rid of hours, replace miles with feet, replace hours with seconds. All right, you're going to need to do a little dimensional analysis, everybody's favorite. 1 mile is 5,280 feet. Miles are gone. 1 hour is 60 squared seconds, 3,600 seconds. So we're going to multiply by 5,280 over 3,600, and that'll convert us to feet per second. All right? Now I've done this ahead of time just so we don't have to spend a whole bunch of time doing a bunch of calculations. This reduces to 22 over 15. So we're going to multiply by 22 over 15, all those numbers. Voila! You didn't know that I was that fast, did you? All right, so now what we need to do is we need to go through and build our trapezoids. We see that all of our bases are 2 seconds. Right? That's 2 seconds, 2 seconds, 2 seconds. So we can use our formula. All right? All right, so area underneath of the velocity with respect to time from 0 to 14, that's going to be 14 minus 0 over, and how many trapezoids do we got? 1, 2, 3, 4, 5, 6, 7. 2 times 7 is 14. And ignore these, because those units don't match what we need. And we'll go 2 times, or 0 plus, and we don't need to do 0 plus anything. 2 times 22 plus 2 times 58.7 plus 2 times 96.8 plus 2 times 120.3 plus, continuing down here, 2 times 134.9 plus 2 times 158.4. And then because this last trapezoid, that height only gets used once, 170.1. All right, so let's go through, let's calculate that. (14/14) reduces to 1, so don't bother. 44 plus 2 times 58.7 plus 2 times 96.8 plus 2 times 120.3 plus 2 times 134.9 plus 2 times 158.4 plus 170.1. And that race car has traveled 1,352.3 feet. And if you want miles, divide by 5,280. And we can see it's gone about a quarter mile. Really? 14 seconds? That's because of the slow acceleration. All right, so in review, trapezoid rule. Find the area of each trapezoid and add them all up. If all your trapezoids are the same base, you can do B minus A, upper limit minus lower limit, over twice the number of trapezoids. That twice coming from the 2 times f of the height at the first trapezoid plus twice f of every other height all the way up to the last one, which again you only use once. And that there is the trapezoid.